Hi guys, today we're going to talk about the Pythagorean Theorem. And the Pythagorean Theorem can either prove that something is a right triangle, or if you know that it's a right triangle, meaning that one of the corners is a right angle, 90 degrees, that you can find a missing side length. So in this case, we're going to determine if this is a right triangle. So I'm going to add some side lengths. And I'm going to show you the formula for Pythagorean Theorem. And for Pythagorean Theorem formula is a squared plus b squared equals c squared. And I'll tell you what that means. So what it's telling me is that if I made a box or a square off the two shorter sides and add the area of them together to the area of the box coming off the third side, that they would equal each other. So in this case, let's take a look. Let me change the color here so we can see it better. All right, so let's take a look at this box right here, okay, or this square. I have this square and the side length is 6, which means this side length is also 6, okay? And if I want the area of that square, remember the area means length times width, so it would be 6 times 6, so the area would be 36, okay? And so let's take a look at this one here. And on this square, the side length is 8, and that means that the other side length is 8. And if I multiply them together to get the area, length times width, I would get 64. That's the area of that box. So the area of this box is 36. The area of that box is 64. So we want to find out this side length, okay? And I'm going to call this C, and I'll explain that in a minute. We want to find that side length. And in order to find that side length, I can use this formula over here, a squared plus b squared equals c squared. All right? Because it's telling me that the area of this square plus the area of this square would equal the area of this square, meaning the area of this square would be 100. Because 64 plus 36 would equal 100. That would be the area here. So if I wanted the side length, I could take the square root of 100, and the side length would be 10, because 10 times 10 equals 100. So that's kind of background. So let me show you how to apply it. Okay, so in this case, A and B, those side lengths are interchangeable. It does not matter which side length is A or B of the two shorter sides. C is very specific. C is always the side that's directly across from the right angle. It's the longest of the sides that we call the hypotenuse. So you'll notice here, this is side length C, directly across from the right angle. The two shorter sides make up the right angle when they meet, but C is the opposite leg. So that's very specific. A and B can be interchangeable. It doesn't matter if you call this one A, you could call this one A and this one B, or vice versa. It doesn't matter. So when I go to plug in the equation, I'm going to call this one A, and I'm going to call this one B. So A is 6, so I'm going to do 6 squared. And then B is 8, so I'm going to do 8 squared. I'm just plugging it into this formula, and I don't know C, so I'm going to call it C squared. And now I'm going to do the math, okay? So I'm going to do 6 squared, and 6 squared is 36. And then I'm going to do 8 squared, and 8 squared is 64, and I don't know C squared. And then I'm going to do my math here. 36 plus 64 is 100, and that gives me C squared. Now, I'm not done yet because I don't want to know C squared. I want to know the side length, which is C. In order to find the side length, I'm going to take the square root of both sides. Remember that squaring something and the square root are inverse operations, and those cancel out, and I'm just left with C over here. And the square root of 100 is 10. And that's how I would get that. So we're going to do another problem. And then I'm going to show you how to find a missing side length that isn't C. So right now we're going to look for C. That's the most direct one. So let's say I have another triangle. Let's say it looks like this. We're going to do one that isn't doesn't come out to a perfect square, just so you can know how to do that as well. So let's say we have this, and we have 2 over here, and let's call this 7. Okay, so we have this, and we're missing this side length. We don't know this one. This is our right angle. And so this side length, since it's directly across from the right angle, I know is letter C. The other ones are A and B, and they can be interchangeable. I'm going to call 2A and 7B. So again, we're going to come back to that formula. A squared plus B squared equals C squared. That's the Pythagorean theorem. And now I'm going to plug in values for A and B. So I know that A is 2, so I'm going to say 2 squared. B is 7. You can see that right here. So I'm going to plug that in, and I'll do 7 squared. And then it looks like this. And now I'm going to do the math. 2 squared is 4. 7 squared is 49 equals C squared. Remember that square means that number times itself, okay? And then I'm going to add that up, and I'm going to get 53 equals C squared. So I want the square root of both sides, right? And the square cancels out the square root. I'm left with C. And then I have to figure out what the square root of 53 is. So from there, you can put it on the number line. I know it's between the square root of 49, which is 7, and the square root of 64, which is 8. So 53 is 4 away from 49. It's 11 away here. Let's call this 7.5 in the middle, right? In the middle, we have 7.5. And so 4 and 11 is going to be somewhere around here. And I would estimate that to be about 7.2 or 7.3. I'm going to call it 7.3 today. And so it's about 7.3. One of the things to notice about this, about C, right? It's directly across from the right angle. It should be the longest side length. And if you notice, we came up with 7.3 for C. So if C equals 7.3, that would, let me make that a different color. That would be the longest side length because we have 7 and 2. So 7.3 would work. Okay, if I came up with 6, I'd have done something wrong. All right, so let's do another problem. And when we do this problem, it's going to look a little different. I'm going to keep this triangle here. And let's say that these are, let's say this one is 10. And let's say this one is 6. And I don't know this side length. Okay, we're trying to figure out this side length. Let me put a question mark here. It seems more appropriate. Right? Again, pay attention because directly across from the right angle is our C side. So 10 is actually C, and that cannot be changed. You can't intermingle that with A or B. C has to be very specific. This one I'm going to label 6 as A, and this unknown I'm going to call it B. All right, so again, let's write the formula. I like to write the formula every time. A squared plus B squared equals C squared. And now I'm going to plug in. So I'm going to plug in 6 for A, so it's 6 squared. I don't know what B is, so I'm going to call that B squared. And then C squared, again, C is 10, and so I put 10 squared. Now, when I do this, I have 36 here, plus B squared equals 100, right? Because 10 squared is 100, 6 squared is 36. Now I'm just solving for B. I'm solving for B. I have to get the B alone. So in order to do that, I'm going to get rid of the 36, minus 36 on both sides. And I'm left with B squared equals 64. But I don't want to know what B squared is. I want to know what B is. So now I'm going to take the square root of both sides. And since the square root and squared are inverse operations, they cancel each other out. And I'm left with B equals the square root of 64, which is 8. And that's my answer. So that's how you would do it if you have a missing side length that's not C. Be really careful. It's very important to be paying attention to which is side length C. Has to be your longest side. Notice again that C is 10 and that A and B have to be shorter than that. B is 8 and 6 is A, so that makes sense. It works. That 10 is my longest side length. That's how you do Pythagorean theorem.